While they proceed, let me briefly introduce to you Mr. Shimizu. Mr. Masaharu Shimizu is currently the president of Global Partnership and has worked for the Japan Bank for International Cooperation, known as JBIC, and the World Bank to facilitate international assistance to developing countries for more than 50 years. Recently, he enjoys learning chanoyu or Japanese tea ceremony and connecting with new tea friends, including Mrs. Nobuko Manabe and Dr. Manabe. Shimizu-san, now the floor is all yours.
Thank you. Good evening, everybody. I'd like to start the fireside chat style talk, an informal conversation with Dr. Manabe. This is his book. Maybe some of you already recognize what it is. Titled Beyond Global Warming. I think this is a monumental book about his scientific journey of climate modeling over 6 decades. At the back of this book, I noticed several words of praise. Let me quickly read aloud the gist of it from just 2 of them. One says, Shukuro Manabe has been the driving force in almost every key development regarding our understanding of the problem of carbon dioxide and climate. Another says, Manabe is a god in the field of climate modeling. I have to kneel in front of God Manabe and then to bow and then pray. But not all the way through this event. Thanks to Mrs. Manabe's very thoughtful advice, we have already adopted fireside chat style this evening. So we can have a little more relaxed conversation in this casual setting. Now back to the main topic. I think I'd like to ask Dr. Manabe the question of fundamental issues. How has the climate changed in the past, and then will it change in the future?
There is no doubt that composition of the atmosphere and the Earth's climate has changed since the Industrial Revolution.
You first mentioned the composition of the atmosphere. How has it changed?
The atmospheric concentration of carbon dioxide has increased by more than 40% since the pre-industrial era, primarily due to the combustion of fossil fuel that produce energy.
I see. Secondly, how has the increased carbon dioxide impacted the climate?
The global mean surface temperature has been stable for over 1,000 years, but it has already increased by about 1 degree centigrade since pre-industrial era. If these energy production activities do not shift markedly, it is likely that these changes will inevitably continue.
Well, if you look at, for example, next several decades, then next several decades, how will it change?
The global mean temperature is projected to increase by an additional 2 degrees centigrade during the remainder of 21st century. In the screen shown here, we will see two main features of the climate global warming. One is land area warming significantly more than ocean, and another is Arctic warming is significantly more than tropics. And the northern hemisphere warming significantly more than southern hemisphere, as you can see here.
I wonder if many people can look at those indicator, color indicator at the bottom. So to the left is a cooler color like blue, and gradually yellow, orange, and red. Red means probably most affected global warming area. So both sides is the same. So it this maybe I sense that you would like to show another figure on the screen. So yeah, this is it, right?
This is, you went up to here.
So yeah. So now we are going to ask the next one, but before then,
Yeah.
please explain a little bit about the simulated figure here on the left. Yeah.
Yeah. This is on the left, you see
That's observed.
observed change in surface temperature during last several decades.
Yes.
You can measure surface temperature and see how it has been changed.
And then to the left is
And you can see the
simulated.
land area warming much more than ocean. And also warming in the northern hemisphere is much larger than southern hemisphere. Ocean is sucking heat down there, and that's why it's a long story. So let me skip explaining in detail, but it's pretty straightforward thing.
Yeah.
So this last several decades, and you can see. Let me see. You can see the scale here, and how this temperature warm up over Arctic Ocean, and much more warming over land than over ocean. And as you go southward near the Antarctic continent, practically no temperature change at all, because the ocean keeps sucking heat downward.
Dr. Manabe,
Uh-huh.
how does it compare with this simulated figure here?
Yeah.
I think many people can, I don't know, see clearly or not.
Yeah.
But this is a simulated change in phase. It says surface temperature due to CO2 quadrupling.
Yeah.
So if they increase the CO2  4 times, then it you show the simulated figures, right?
That's right.
Yeah.
That's right.
And then that it looks like very similar. So that means you predicted
Yeah.
pretty well.
Which is, we have a trouble in predicting daily weather. But my golly, we seem to doing decadal prediction using climate models. I am very proud of it. But anyway, uh, around in the southern hemisphere, so what is happening is here, it's warm. In the northern hemisphere, it's warm much more than southern
Yes.
hemisphere.
All right.
And the ocean keeps sucking heat downward.
Okay, in relation with that point,
Yeah,
may I ask another question?
yeah,
Please sit down.
yeah,
And then,
yeah. I'm okay.
Okay, okay.
I'm okay. I did too much physical therapy.
Okay,
I got
all right. Maybe this is part of your
aches.
exercise time.
Aches all over the place.
Okay, all right.
Ah,
Now, my question is, how will the warmer surface temperature
yeah,
of the globe affect the precipitation around the world?
yeah. If temperature gets warmer, it evaporates more. And it evaporates more, sooner or later that water have to precipitate. So precipitate more. And that's how this um, the precipitation changes, because if the climate, the temperature changes, then precipitation changes.
Yeah, but the precipitation, I think, evenly spread all over the world.
That's right. But warming is much more, so evaporate more in the northern hemisphere.
Darker part.
Yeah, that is the reason.
Yes.
Although that's a simplistic explanation. So if I keep going in there, then you may get even more confused. So
Okay.
I will stop.
Okay. All right. Thank you. Okay. All right. Then it looks like the trend of climate change
Yeah,
is not even. Maybe depends on the location. Some part is hotter and then may cause more rainfall or precipitation.
yeah,
Right. But some part is drier than before.
drier.
I see. Okay. All right. So now,
If you put more water someplace here, other place get drier, doesn't it?
yes, yes. So
Right?
that's right. Yeah.
Yeah.
So the maybe for the close future, uh, then what do you think will be the impact on the ecosystem and then also the human society after this lot of global climate change?
the So observation indicates that frequency of both drought and flood has been increasing. That's what you said.
Yeah.
Yeah. That is right. Unless dramatic reduction of greenhouse gas emission are achieved, global warming is likely to exert far-reaching impact upon the ecosystem of our planet and human society during the remainder of this century and for many centuries to come.
Wow. Your description makes me imagine that some gigantic alarm bell in the sky or somewhere else keeps ringing louder and louder as if we are approaching to the edge of hell.
I don't know whether it will be hell or not. But I can tell you one example you can easily visualize. In the future, climate of our planet will likely resemble what it was during Mesozoic era when dinosaurs were roaming on this planet. If we keep burning fossil fuel, the coal in this case particularly, at present rate during the next several centuries. So we keep burning coal like anything. And so you get climate which dinosaur likes.
Okay. Aha. Dinosaur.
Yeah.
They are getting more popularity these days, particularly among children, through many cartoon storybooks or animation movies. But I hope they will soon scientifically understand the comfortable climate for dinosaurs is not really the one for human beings to survive, right?
No. You explained huge issue impacting ecosystem and human society of our planet. Okay.
The next question would be, what should we do?
That's a good question. Yeah. And so, as you may know, it has become possible to predict climate change reasonably well using mathematical model of climate that mimics the coupled ocean, atmosphere, land surface system, which is our planet. Uh, however, it is so it is much more difficult. Yeah. So if you look at this figure, models seem to predict pretty well. As a matter of fact, it's doing better job than weather forecasting. But you're talking here about climate change over centuries here. So if you keep burning CO2 in the present rate over next several centuries, the climate gradually warming. After several centuries, climate become a perfect climate for dinosaur.
Yes, yes. But after that, then
Yeah.
what kind of, you said that it is easy for you to kind of predict.
Yeah.
But is there any more difficult thing than prediction? Then predicting the climate, there may be consequences.
Yeah, as you can see, it's doing pretty well. As you can see, we seem to predict climate change during last several decades, which is during last several, this one, using climate model, this is CO2 quadrupling. So you keep increasing, pumping more and more CO2, you get this. And my golly, they look very similar.
Yeah. Okay. Then I have another question.
Yeah.
Next stage. Then how do you see the impact of climate change
Yeah.
on our society?
Yeah. The as you know, economics of China Middle East, Southeast Asia, and Africa are deteriorating, affecting profoundly international trade, commerce, and the politics of the world. In my opinion, Japanese Chamber of Commerce and Industry of Washington, D.C. and New York could play critically important role for tackling this very challenging issue.
They are certainly overwhelming and complicated issues, aren't they? At this point, I'd like to mention that this event is co-sponsored with Japan Commerce Association of Washington, D.C. and as a part of their monthly seminar series. So there must be several, I think, members of JCAW. So I am expecting to receive comments and questions from the audience, including those members of JCAW. With this in mind, I plan to have an interactive question and answer session toward end of this event. In between time, the next things I'd like to ask Mr. Manabe. When we see our children or grandchildren, naturally we think of their future. So I would like to take this occasion to ask your advice for the future generation regarding climate change.
In my opinion, we should not count too much on good luck in future. As you know, coal is the cheapest and dirtiest fossil fuel available in future. It may be very difficult to stop using coal, preventing the rapid increase of carbon dioxide in the atmosphere, thereby preventing global warming. Major effort should be devoted for increasing the usage of alternative sources of energy, such as solar, nuclear, and wind energy.
It is encouraging to notice growing signs that people, particularly among younger generations, are becoming more sensitive to global warming. Therefore, more active in taking actions to try to prevent it, right? So now, since we have a little more time, so in the past few years, generative AI, artificial intelligence programs have become available to the public. And they draw the huge attention of people around the world. Related to that, my question to you, Dr. Manabe, is in what ways do you see AI and machine learning playing a role in enhancing our understanding of climate change and its impact?
In my opinion, I will go to this one. In my opinion,
No. Next one, after that.
This one, right? Yeah.
Next one.
Oh, I skip this.
Oh, no.
Yeah, no, let's try this. In my opinion, next big scientific issue. The global warming is a major scientific issue. I may have convinced you to some degree. But next big scientific issue is the global spreading of infectious disease, caused by bacteria and viruses. As you may know, it has been noted that global warming and associated change in precipitation induce spreading of infectious disease.
Thank you for your insight.
Yeah. Oh, just a moment. I may have even. Yeah. Okay. Now.
So based on the lessons we learned from the COVID-19 circumstances, people and the governments around the world must be in a better position to be alert enough to any early indications of different kind of infectious diseases and to related medical research from early stage. So, Dr. Manabe, shall we move now to question and answer session for the next 10 minutes?
Q&A session. And I would like to invite the audience to ask questions to Dr. Manabe. For those of you who would like to ask a question, please raise your hand first and wait for a microphone to be passed on. Okay, please.
Hi, thank you very much for today's talk. I'm actually studying and working on climate risk, and I'm going to be a faculty from this summer. And I have been very excited, but also I wanted to ask you, in the US, climate change has been very politicized, and I see that some people are really believing it, some people have trouble thinking even about climate change being a fact. And I wonder, this is really hard to validate sometime when you predict something using a model. So I wonder how you convince people in this country for a long time about climate change.
How I convince?
People in the US, because people sometimes don't even believe in climate change at all in this country.
Yeah. I think so. This is. I hope I convinced you. Carbon dioxide keep increasing at present rate. Now, that if you keep doing this for several centuries, and then temperature keep going up and up and up, and then the climate will be the climate which dinosaurs enjoy. And I wonder whether we can afford to. Of course, you may not be alive several centuries from now, but the consequence of this climate change is awful. A dinosaur may enjoy it, as I pointed out. So I think several centuries from now you may not be alive, but it's not good for human race, the climate at that time. It's torrential rain, drought, and temperature is hot, very warm and hot. And so, even though you may not be alive several centuries from now, but I think we should think of this issue very seriously.
I noticed one thing in
Yeah.
your book.
Yeah,
You emphasized why global warming is happening. Related to that, you said greatest value of climate models is not just their utility for making predictions,
yeah,
but also their ability to provide a deeper understanding of how the climate system works.
yeah, yeah.
I wonder to what extent the climate models' ability in deepening understanding, deep understanding about the mechanism of the climate system have convinced some groups of skeptical people. So, about the view that carbon dioxide is the major cause of global warming.
Mm.
So, maybe my understand or the question I had at the time was, would you suggest any further area to research or ways to prevail this understanding more effectively
Yeah,
to strengthen the convincing power
yeah,
of those your theory of global warming
yeah, yeah,
based on the carbon dioxide increase?
yeah. What it is a chemist, in order to study chemistry of substance, they do laboratory experiment. What we can do use a climate model is to do, instead of laboratory experiment, we do numerical experiment. So you can, if you want the uh, climate change, you can do all kind of experiment. And if you want to affect, for example, effect of Tibetan plateaus on climate, you can get rid of Tibetan plateau from climate model, put back in, take them out, and climate change greatly. And or if you want to see uh, another interesting experiment is to shut off the Drake Passage. And so you shut off circumpolar ocean, which has a profound effect. See, you see global warming completely different between northern and the southern hemisphere. And that is affected by the fact that southern ocean current go around latitude circle. Northern hemisphere always there's a barriers. When you shut off the Drake Passage, climate completely changes. Or if you want to know the Tibetan plateaus, you can get rid of Tibetan plateaus from your model. And I have throughout my life, I have a great time. Or you can open up Isthmus of Panama, open up between ocean current, water between Pacific Ocean, Atlantic Ocean. Climate changes greatly. And so that if you are interested in this climate change, I recommend you are very lucky than I has been. Because my golly, now you have a supercomputer and you can do countless numerical experiments. And also, uh, you have a great observation now. And so I hope that people who enjoy climate and climate change will enjoy great time conducting countless numerical experiments.
Dr. Manabe,
Hi.
I remember you mentioned earlier
Yeah.
that there will be a lot of impact of global warming
Yeah.
on the human society. And then you also mentioned that those economic problem of China, Middle East, Southeast Asia, and
Yeah.
Africa deteriorating and then affecting profoundly international trade, commerce, and the politics even. You mentioned that.
Yeah.
So maybe this is the area beyond the global, I think, climate modeling area. So maybe we should throw the questions to maybe some of the members here, like the members of JCAW, if you have any kind of idea or what you have been doing already to kind of reduce those trend of global warming at this rate or something. I wonder if someone in the Chamber of Commerce person try to respond to that. Otherwise, maybe we can take another question.
Okay, shall we go on to the next question?
Yeah.
Oh, okay.
Sorry.
Yes, please.
Hi, my name is Mika Takagi. I represent the Japanese Ministry of Economy here in Washington, D.C. And also I represent the organization called NATO, which is funding agency under the Japanese government to help companies to develop clean tech technologies. So I feel obligated to say a few comments. So Japan has a really low energy independence. So we have to rely on imports, and we still have to rely on fossil fuel. But we are still trying to install solar, wind, nuclear power, and other forms of clean energy. But we are still struggling to get rid of fossil fuel. So that's our situation. But we are also, by doing that in Japan, we are also helping other Southeast Asian countries to do transition for cleaner energy. So, and we do collaborate with US and EU and other developing countries to develop more clean technologies. We've been struggling because each country has different situation, and we still have to think about the global south that has to develop economically to feed their growing population. So it's a really difficult balance between pursuing clean energy and also pursuing economic prosperity. So we are all struggling, and so that's my comment. And also, I have a question for Dr. Manabe. Do you have any suggestion for Japanese government to pursue green transition?
Any suggestion for green transition to the Japanese government?
It's not easy
Yes, of course.
not to burn coal.
Yeah.
As I pointed out earlier, coal is the cheapest energy source, and it's dirtiest. And even though people realize that coal is very harmful, we cannot afford not to use coal.
Why?
And this is the problem which we face. And China knows that coal is very harmful, but China feels they cannot afford to stop using coal. They are exporting coal. And so this is a sort of international commerce and trade. And so I wonder this Chamber of Commerce in Washington and New York collaborate, tried how to minimize the usage of coal. And the, you can make a great contribution. And this involves diplomacy, and all the diplomatic interaction. And this is one thing which, yeah, which sort of you people.
I'm not representing the Chamber of Commerce, but so anyway, probably you throw the ball to many audiences, including the Chamber of Commerce members. So probably we will see some kind of response, I think, over the time. Yeah.
Yeah, yeah.
So I think time is now approaching to the
Due to
question.
Uh-huh.
Before concluding, going to those kind of final remarks, I'd like to ask you to give some, I think, a few words of advice to all the people here.
Yeah, yeah, I was preparing this thing. Yeah. So the one of the things I would like to do, young people, the, do something which you can enjoy. And climate research of climate modeling is very enjoyable. You can carry out all kind of numerical experiments. For example, you can evaluate the effect of Tibetan plateaus on climate without getting rid of Tibetan plateau on the computer, right? And so, and of course, climate system is very complicated. If you put everything on the climate model gets hopelessly complicated. And so this is one of the motto I have is, so that when you construct a climate model, you have, my motto in my whole life is simplicity and balance. Don't compete with nature in complexity. And they boil down to essential thing, throw out all the extraneous stuff, less important stuff. Get on the most important thing in the climate model. That's one.
Simplicity and balance.
That's one recommendation. And another thing is, there is something in Japanese, suki korso mono no jouzu nare. And do whatever you can enjoy. And Japanese people, young people tend to be, do something which is kakko ga ii. No, do something you enjoy in your life. And so this is my message. and throw out all the garbage out of it. Don't try to compete with nature in complexity, because the nature is infinitely complicated. So the motto of this thing is simplicity and balance. This is my motto in my life.
Great. Thank you very much.
Yeah.
I hope this will come to your old mind well printed. I hope. So please go ahead.
Okay. Once again, please give him a big applause. Dr. Manabe, thank you very much for coming to talk to us in person tonight.